So in this lesson, we are going to prove two big theorems. Now, if you remember, there are two big kinds of evidence or reasons that you can use when you're doing proofs. Three, really. There's definitions, there's postulates, and there's theorems. Okay? Definitions and postulates don't need to be proven. However, theorems do. You have to prove theorems before you can use them. So what we're going to do in this PowerPoint is we're going to go over some things you should already know, and then I'm going to introduce two theorems to you. We're going to prove those in this PowerPoint so that afterwards you can use them all you want. All right, so things to remember, you know all of this stuff. Whoops, that should be an angle symbol. Every single one of these postulates, these definitions, you know all of these. Okay, or you should know all of these. If you don't, bring out the flashcards and write these down. We will be using these in these theorems and to prove these theorems. Okay, so that's just kind of how proofs go. As soon as you have proven something to be true, you can use it as a reason later on. But unless you've proven it, you can't do it. Okay, since you should already know these, I'm going to move on. If you don't know them, pause the video now and fill this out or write these down. So the first of our two theorems is the midpoint theorem. There it is right there. If M is the midpoint of AB, then AM is 1/2 AB and MB is 1/2 AB. Now if you look at this long enough, that seems to already make some sense. Because if M is the midpoint, then these two pieces are equal, which means that M cuts the thing in half. So yeah, it makes sense that AM is half of the whole segment, and that MB is half of the whole segment. That makes sense. However, it's geometry, so we have to prove that it does make sense and that it's logically sound. Thus, we get to the proof. So as always, the first thing we're going to do is read it and annotate our picture. So we are given that M is the midpoint of AB. Okay. And we are trying to prove, there's M, we're trying to prove that AM equals 1/2 AB. All right, so write my given. And the reason is that this is given. Now, let's look at the picture and think this through logically about what we're going to need. I know I have a segment, and I have AM and MB. Now, AM is a piece of the segment, AB is the whole segment. So I'm probably going to be using the segment addition postulate at some point in this theorem, or in this proof. I'm also told that M is a midpoint. And I know that because of the midpoint, as I annotated, these two things are equal. And that's just off of the definition of midpoints. All right, so that's a little piece of logic that I used. Okay, so with that information, we should be able to at least get started. So I'm going to go ahead and put these in my proof just so that I have it. So I'm going to put in my segment addition postulate. AM plus MB is equal to AB. And this is segment addition postulate. All right, and then I have AM is equal to MB because of the definition of midpoints. Okay. Now, from here, I am proving this top one. So I need the equation to only have AM. I need to have AM equals AB somehow. Well, as I look at my segment addition postulate and my definition of midpoint, I notice that I have AM is equal to MB. So what I'm going to do is I'm going to substitute AM in for AB, or MB. So in my new line, I'm going to have AM plus, and I'll change color so you can see what I changed, another AM is equal to AB. Oops. All right. So all I did was substitute AM in for MB because those two things are equal anyway. Substitution. From here, it's actually algebra. I now have two AMs on this side. And then since I need AM by itself, I'm going to divide away. So now I have AM is equal to AB over 2. Or another way you could write that is 1/2 AB. And here I'll actually rewrite that underneath so you can see it better. And we got here by dividing. Okay, now I'm going to check. I have my last line of the proof, AM equals 1/2 AB. That is the exact same thing as what I was trying to prove. So I can sign off and I'm done. Now it does say you could have proved it this way. You could have plugged in MB. So in this step right here, instead of plugging in AM, what you could have done is you could have plugged in MB over there. So you would have had MB plus MB is equal to AB. And it would have continued on the same way, just with the different letters. But it would have been the exact same thing. Okay? So in this proof, the two things you needed to have were this segment addition postulate and the definition of midpoint. Once you had those in your proof, you needed to recognize that since the two things were equal, you could substitute it into the equation. These are patterns that you see the more you do them. So if you're not seeing them just yet, that's okay. A trick that you can do, okay, is to take this proof, write it on a separate sheet of paper, and then resolve it. And just keep resolving this proof. Keep trying it over again. Keep rereading it until you can see the pattern. Another trick, as I just said, reread it. Read it out loud. Talk yourself through it. Read the statement, read the reasons. Okay? All of this will help you kind of get a grip on the logic of it and help you see the patterns. Right. Now that we've proven the midpoint theorem, we get to actually use it. So given that M is the midpoint of AB, or N is the midpoint of CD, prove that so here's all we're told. We need to prove that AM is equal to CN. So I have my given, I have my proof, now I need to draw my pictures. So first off I have AB. Oops, you kind of can't see that. Okay. So we have A, B with M in the middle, and it's a midpoint, so I'm going to make sure to draw my congruency symbols. And then we're told that we have a line CD with N as the midpoint. So make sure you use double congruency marks because that's all we're told. Okay. Then we're told that AB is congruent to CD. So then we have this up top, 1, 2, 3, is congruent to this down here. All right. So the whole segments are congruent to each other. And we need to prove, here's where drawing comes in handy, we need to prove that AM here is congruent to CN. Now, when you're going to start your proof, again, look at the picture and try to understand where you think you're going to have to go. So right away, I know I have two segments, so most likely the segment addition postulate is going to have to happen, especially if my holes, if both segments are congruent to each other. I can kind of look down and see that in order to get the pieces congruent, I'm going to have to set these two equations equal. All right? If that went beyond you, don't worry, we'll get there in a moment. I have midpoints, so I'll need the definition, but I've already proven my midpoint theorem, so I'm going to use my midpoint theorem. By the way, this is my abbreviation for theorem. Okay. Now, if you're not comfortable with the midpoint theorem, yes, you can use the normal method of using the definition of midpoint to figure this out. It's just going to take forever. So let's go ahead and start. First, the given. And as a reminder, if you don't understand any of my shorthand, please ask me about it. Don't just sit in silence. Okay, so now that we have our given, I'm actually going to use the midpoint theorem because, we're supposed to be using the midpoint theorem. And I know I've got to get to AM and CN. So I'm going to use the midpoint theorem with those two. So I'm going to write AM is equal to 1/2 of AB, and that CN is equal to 1/2 of CD. Okay, and I know this because of the midpoint theorem. Okay, now in my given, I notice that in my given, I'm told something about AB, and CD. AB and CD are equal. So that means I could set these two equations equal to each other, which would go a long way to having the two pieces equal to each other. However, I can't do that just yet because I have 1/2 AB and 1/2 CD. So first thing I got to do is move the 1/2. So now I have 2 AM is equal to AB, and 2 CN is equal to CD. And this is the multiplication property. Okay. Again, the reason why I had to do that was because in my given, I know something about AB and CD. I know nothing about 1/2 of AB and 1/2 of CD. It sounds like I'm splitting hairs, but it really does matter. But now that I have AB and CD, I can plug in the equations into this equation up here. So instead of writing AB equals CD, I can set the two equations equal to each other. So I have 2 AM is equal to 2 CN. And this is substitution, because technically I'm still substituting it back in to this equation up here. Right. But now in my proof, I just need a normal AM and a normal CN. So then my next step is going to be to divide the two away, and then I'm left with AM is equal to CN because of the division property. All right. Our last line matches the proof, so we are done. Okay. Moving on to our last proof is angle bisector theorem. Okay? The angle bisector theorem is the exact same thing as the midpoint theorem. It's just that midpoints are for segments, angle bisectors are for angles. It's the exact same wording otherwise. So I'm going to let you pause the video to write this down. I'm going to move on to the proving. So first thing I'm going to do is annotate my picture and write down the information that I used. So I have that BX is the bisector of angle ABC. So I know that ABX is congruent to XBC. And I know that because of the definition of bisectors, of angle bisectors. Okay. And I have two angles. I have a whole angle. I notice that in my proof, I have a whole and I have a part, or a part and a whole. So I'm going to also write down the angle addition postulate, because odds are we're going to be using that one. All right, and now to write the given. So there is our given. Ray BX is the bisector of angle ABC. And now we are officially ready to get started. Okay, So in my notes, I have that definition of bisector and angle addition postulate. So I'm going to go ahead and include those. Okay, so I have that angle. I'm doing angle addition postulate first. Angle ABX plus angle XBC is equal to angle ABC. And this is angle addition postulate. And then I'm going to use my definition of bisectors. So angle ABX is equal to angle XBC. And I know that in a lot of these past proofs, I've been writing notes off to the side. I don't know if I've ever actually told you that these are just notes. This is just me thinking. You are welcome to copy that and have notes off to the side. I actually encourage it, but having notes is not part of the required proof format. Okay, now that I'm here, going back to the proof, now that I'm here, it's the same exact logic as we used in the midpoint theorem proof. So here I am told that these two things are equal. These two angles are equal. And I need to have angle ABX in my equation set equal to angle ABC. So I'm going to plug angle ABX in for angle XBC because those two things are equal. Oops, plus. And I can do that because of the substitution property. And then just like last time, it's down to algebra. So now I have two angle ABX's on this side. And then I can divide that. I know that because of the addition property. And then I can divide away 2. So angle ABX is equal to 1/2 angle ABC. This is division. I cannot spell this word right today. Okay. And there we go. And that's the end. And this is also the end of the video. Again, if you have any questions, if you didn't understand any of the proofs, first go back and reread it out loud. Okay, so explain it as if you were trying to teach it to somebody else. And sometimes just speaking it out loud, re-looking at the pictures, that can clear up a bit of the confusion. If that fails, try rewriting it. Try resolving it. You already have the answers. Try resolving it out and seeing if you can do it on your own. And sometimes re-looking at the problem helps you out. When in doubt, always ask me in class. All right, I'll see you next time, guys.